Hi, Chris Kuzmal here. We have a failure in our test cases for our binary search tree that was that came into existence when we implemented the insertion method. We think the insertion method is correct. We don't actually have test cases for insertion explicitly, so we're unsure about whether or not the test case itself is correct, but we strongly suspect that our previous insertion method or something else uh, is wrong. The test itself is wrong, or something along those lines. The problem is that we don't know which one of the failures is, because we did not write a good test program in as much as it wasn't verbose on the failure, which is to say it didn't print anything out when it failed, and so we don't know which test failed. All we know is that one of the tests failed. Well, I'm going to take an opportunity to do a crude binary search technique on finding a bug in our binary search test code. And so what I'm going to do is I'm going to comment out almost all of my test cases. If I were a little bit more clever, maybe I'd comment out half of them. But for the moment, I'm just going to come out enough that I'm 90% sure that I will pass the two tests that I currently have. And they do both pass. So now what I'm going to do is I'm going to take the beginning of my comments and I'm going to move it halfway down, approximately, maybe almost halfway down. We'll put it here. So I introduce half of my test cases now, half of the unretried test cases, and see whether or not any of them succeed or fail. And the technique here is making it so that I'm rapidly narrowing down where my problem is. So now I'm going to introduce half of the remaining test cases and run and see if any of them fail. And none of them fail. So I'm left with either test delete 1 or test delete 2, and I eliminate one more or reintroduce one more, however you want to look at it. And it will succeed. So that narrows it down. So indeed, it's test delete 2 that fails. So let's take a look at test delete 2. It's not verbose. It's not showing us what's going on. And it's sort of interesting once we get down to it. Here's test delete 1. Here's test delete 2. And test delete 2, interestingly, it returns true when it does succeed in finding an element. So this is a little counterintuitive. We might have thought that the test delete was failing because it was deleting the wrong element and still finding it, but in this case, it's designed to delete an element that it then checks to see if the other element remains. But the other element apparently does not remain. That suggests that we actually have a failure in our delete method rather than our insert method. So let's take a look at our delete method in, is it the node.java or is it the linked list.java? I'm sorry, binary tree.java. So here's the delete, and now suddenly we realize, oh my gosh, we haven't implemented this delete is the one we used that was analogous to a linked list. And so everything's referring to a left child here. There's no right child references at all in the delete. We know this can't possibly be correct in every case. And so we know, so we have to implement delete or re-implement delete. And indeed, if you're following Corbin-Elias and Rivest, the next method that they call upon to be implemented is delete. They don't bother to do delete until later on, but then again, it makes it harder to test the code as you go along if you don't have some version of delete in place. So next time we will begin to implement delete.